Welcome to EDU World Space.
Here we're going to look at causality in special relativity. Causality is the idea that an event in frame 1 causes another event in frame 1. And the worry is, will special relativity, in particular the Lorentz transformation, ruin that idea? So this is a topic that is explored much in science fiction. But in order to show that causality is preserved, we're going to need the Lorentz transformation equations. And we'll just stick in one dimension. So we have the transformation on the position coordinate between frame unprimed and primed, as well as the time coordinate between primed and unprimed. And to start off this, we'll take a look at a simple case to see how this goes. Let's have a case where we'll put unprimed frame. We'll have two events occur at the same location. And these may be on Earth. We'll call Earth the same location, which is x2 equals x1 for the two events. And event 1 at time 1 is your mom is born. Okay, so mom is born on Earth. And event 2 at time t2 is you are born. So that is definitely a causal connection there. So now let's see what those times look like in terms of frame S prime. So we'll put somebody in a rocket ship out there. We don't know where they are, but we're most interested in the difference T2 prime minus T1 prime. And for that, we are going to use Lorentz transformation on time. We'll call these equations 1 and equations 2. So this is fairly easy to put in for equation 2. Basically, the positions x are the same. So we could write all that down. And T2 prime in terms of T2. Okay, and take the difference. And of course, the position information will go away. But what we see very readily is that the way that those two times are organized is still T2 comes after T1. In the Earth frame means T2 prime comes after T1 in the moving frame of this rocket ship. Yeah, let's just make it a rocket ship. And the reason why we can say that is we know that gamma is a positive quantity, just a constant that's greater than 1. So the time order is perfectly valid. Although the gamma factor shows time dilation. Okay, so let's take a look at a slightly different case. Let's kind of turn this around and make two events happen in frame S. And ask ourselves the question, what are the conditions in frame S so that the time ordering gets mixed up in S prime? Okay, so let me see if I can write that down. How to have two events in S such that T2 is greater than T1, but T2 prime is less than T1 prime. Okay, is that possible that you can have one type of ordering in S, but a different ordering in S prime? We'll see what the conditions are, but of course, the thing that we're going to have to do is make the two events happen at different locations in the Earth frame. Okay, so we're going to assume that T2 is bigger than T1 in the Earth frame. And again, let's take a look at the transformation equation on time. We have T2 prime minus T1 prime now. There's still a factor of gamma. There's still the correct ordering of T2 and T1. But there's this negative sign. And to make life a little bit easy, here we'll put in our position difference. We'll also assume that x2 coordinate is bigger than x1. We don't have to, but that just is going to help think through the signs. So we know that T2 and minus T1 is greater than 0. In order for the order to be switched, that's awkward, for T2 prime minus T1 prime to be reversed, we must have the negative second part be bigger than the positive first part. Okay, so that's a fairly clear statement. That's how you can get a negative T2 prime minus T1 prime. And with a little bit of reorganization, we can see what this last statement means. C squared over V then has to be less than delta X over delta T. And we can think about delta X as delta T divided by delta T as the way information traveled from point 1 to point 2 in the Earth frame. And what this basically says is that in order for this to be true, that delta X over delta T had to have been greater than the speed of light. And the way we see that is V has a maximum of the speed of light, at least as far as we know. So C squared divided by C equals C. And like I said, the way to interpret the delta X versus delta T is the information exchange, the causality between point 1 and point 2 in the Earth frame. So the only way, the final summary is only way to violate causality in S prime frame is if the two events in the Earth frame were never causally connected, or it was impossible for them to be causally connected. And they were not connected in that way because of the finite speed of light. Okay, and the other way people talk about special relativity is they talk about the space-time interval between two events in space-time as being either space-like or time-like. And space-like separations have this nature to them. They are so far apart that you cannot connect them with a signal in the time between two events.